Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little Q&A button. Click on that, hit submit, and we'll get to those questions at the end of the session. If you're joining us on YouTube, just make sure you use the live chat function wherever it happens to be on the screen of the device that you're using, and I'll get to those questions and comments a little bit later as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So, always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years underhood experience for me. So our topic at hand today, continuing our component testing series we've been doing. And today we're talking about diesel fuel injectors. So gasoline fuel injectors are a little bit different than diesel fuel injectors. And so there's becoming some similarities in between them. So direct injection, gasoline direct injection, and diesel direct injection with those types of injectors are very similar in how they operate. They're pretty much identical. But the vehicles do operate a little bit differently. So this is going to be focusing on mainly the truck side of things over here in the States. I know there's also diesel injectors over in Europe. There's a lot in the diesel engines in the cars and such over there, and they'll use a lot of the same types of principles and same type of injectors. So you'll be able to kind of cross over if you're over there. So we're going to talk about gasoline versus diesel engines first, because I know a lot of you folks might not even deal with diesel in your day-to-day. It might just be a gasoline engine shop. They work very similarly, but there are some differences. We'll talk about that. And then we'll go through the GM and Dodge common rail injectors, the Ford HEUI injectors. So those would be the hydraulic controlled injectors. And then piezoelectric injectors, which many manufacturers have gone to in the more recent years. And then we'll talk live through scanner functions and scope testing on a few different sample vehicles. So gasoline versus diesel, what's the difference between them? Well, we know they're internal combustion engines, and they both need the same four main ingredients. So they need air, they need fuel, they need compression, and some sort of an ignition source. Notice how we say ignition source, not a spark, because that's not how diesel works. Air is the same. They both need air, but how they use it's different. So gas engines use a throttle body to control the air. That controls the amount of fuel being used, which controls the RPM. Versus on diesel engines, they don't really use a throttle body system per se. The RPMs are controlled by the amount of fuel being injected into the vehicle. Now, most modern diesels also use a turbocharger. I think probably just about any diesel you're going to find nowadays would be a turbo diesel vehicle. So it compresses the incoming air, and in turn, they can burn more fuel to make more power. That's why diesels have a ton of torque with them as well. Fuel's different too. So gasoline is more refined. They're both petroleum products, but the gasoline has less energy available, and auto ignition temperature is going to be higher than diesel, about 475 degrees Fahrenheit. Versus in a diesel, it's not as well refined as gasoline. They say it's a lot more raw. Does have more energy available, and its auto ignition point is lower, around 410 degrees Fahrenheit, which helps us in the way the combustion process works. Compression's different too. Gasoline engines are going to compress the fuel and the air before igniting it with a spark. And compression in a gasoline engine is around 100 to 150 psi, depending on the vehicle. Diesel engines are going to use the compression to compress the air before it injects the fuel. So we're going to superheat the air by compressing it. That's what ignites the fuel. So it's the actual compression of the air. The hot air is what ignites the fuel. Compression in a diesel engine can be 500 psi or more per cylinder. So there's some differences we're seeing. And the ignition is different. So after compressing the air and fuel mixture in a gasoline engine, it's going to need an ignition source like a spark plug or multiple spark plugs. Generally, the coil will supply that spark to the spark plug, both running at high voltage, 10s and 20, 30,000 volts, in order to get that spark to jump in order to ignite it. Whereas, as we said earlier, after we compress the air, the diesel fuel is then injected into the cylinder, auto ignites because the temperature is higher than its flash point. So it highly compressed air, very hot, flashes the diesel, and that's what gives us the ignition source. And diesel engines, because of that, don't need an external ignition source. Now, we're not going to get into glow plugs or anything like that, but glow plugs are really only used to heat up the air that's in the cylinder before it gets compressed if it's cold outside. So as it compresses, the temperature might not be quite hot enough to get it to ignite. So we use those glow plugs to give it a little start in the right direction. So combustion in the gasoline engine, as we said, we have the piston that goes up and down, just like in the diesel engine, but we have our combustion chamber here, and we have an ignition source with the spark plug, of course. And then on a diesel engine, in this case, the cylinder itself is really the combustion chamber, and you see how that's direct injecting right into that piston. You see how the little curved sections of the piston, it's not a lot of space there. It gets very, very close to the top of the cylinder head. So really, it's just enough room for that fuel to get in there and ignite, and then, of course, pushes it down. So on these direct injection type vehicles, you're going to have the injector in the middle, and the piston head is shaped to create the turbulence instead of having it swirling in the combustion chamber like we would on a gasoline engine. So now that we got the differences, let's talk about a few of the different types of injectors. So first off, we're going to talk about common rail injection on the Duramax and the Dodge 5.9 and 6.7 liter engines as well. They use pretty much the same type of system. So they use high pressure fuel provided by a camshaft driven pump, and they are electronically controlled injectors. Each unit injector has an electrical connector and high pressure fuel connector on them as well, and they have a common fuel rail for it as well. So here's just a schematic drawing of one of them. So we got the fuel tank there, goes in through this high pressure pump that runs off the camshaft. So if you watched my gasoline direct injector course, then we talked about that as well. So it's got a little diaphragm in there, and it runs off the end of the camshaft, and it pushes the fuel into a smaller space, which allows us to increase the pressure. Now, in this case, we have the common rail, it's pressure sensors, pressure limiters, and then the pressure goes into the injector, and then the injector is electronically controlled by the computer, which is fed by all the sensors that tell it, well, here's how much fuel we need to inject. So 100-volt injectors in this case, it's a solenoid, all done with a tiny little check ball right here. We got that little check ball kind of right in the middle, and that's what it's done. When that check ball opens, the fuel that's holding the needle closed is able to bleed off, and the injector is going to open. It's going to give me a constant source of 5 to 35,000 PSI when it comes out. So the high pressure fuel holds it closed on the top. Right. So when it is closed, the high pressure fuel comes in from the side, holds this pintle down, so it will not spray the fuel. And all we have is that little check ball right there holding it back with the spring. When the injector opens, the electromagnet pulls up on this assembly here, pulls up this, I guess they call it a pilot needle. It's much larger than the other needle. Pulls it up off the seat, allows it to bleed off, and then that's what allows the fuel to spray. So fuel comes in here, bleeds off the back, and then this opens due to the spring, and then it pushes down and sprays out down the bottom. So that's one type, that's one style of injector that you'll see out there. So like I said, common on Dodge, Duramax, that sort of thing. So you can see just another kind of cross view of that. We got the nozzle there, and it shows us the different rate of injection and pressure. If you were to look at this on a scope, we have our current. So the current peaks at the beginning, and then it kind of stays level to hold it open, and then it closes. The lift, we'll see how high it lifts. And then fuel pressure, of course, drops off a little bit because we are spraying. And then this is the injector rate as it opens. So we can see how it opens. Once it's open, holds it, maintains it. And that's kind of how it works on that style. So that's generally like a electrical connector on the top, return line, and a pressure line. Pressure lines on the side, return lines on the top. And then you have your nozzle down. Now, HEUI, so this is on your older Ford vehicles we're using this. So on the Ford Navistar Power Stroke 7.3 and the 6 liter, And what this does, it uses high pressure oil, motor oil, to magnify the fuel pressures. So it's also electronically controlled like all the other ones. Has an electrical connector, has lower pressure fuel than the previous design we looked at, so 45 to 65 PSI in that case, but high pressure oil. So it uses an injector pump or a high pressure pump for that as well. So you can see the pump right there. And we need to have good oil pressure for this in order to work. So we have the injector there, and then we can see the high pressure oil branch, high pressure standpipe, high pressure oil rail. So we got an oil rail and a fuel rail. It's got a high pressure pump cover, and the high pressure pump once again runs mechanically as well. So on these, we got an electric solenoid on the top. We have high pressure motor oil coming in through the side and low pressure fuel coming in through the bottom here. So how's it work? So we have, like we said, the solenoids on the top. Here's a nice cross section of this entire unit. We have the oil chamber in here. We have a poppet valve. We have an intensifier piston. And then we have a fuel chamber down here and the nozzle down here at the end. So when the electronic solenoid is energized by the FICM, so that's the fuel injection control module that they have on those, it pulls the poppet valve off its seat because it was held in its lower seat via spring. And that closes off the oil drain pathway and opens the inlet for high pressure oil. So you can see the difference here between where we don't have oil in there and the inlet's there. And then the oil is allowed in, which holds this down or pushes this down on the spring there. So there's your solenoid, your oil chamber, and your poppet valve. So when the poppet valve moves due to the solenoid pulling up on it, it allows oil to flow through the chamber and push down on the intensifier. The intensifier piston has 7 times more surface area than the plunger, which means 3,000 PSI of injection control pressure on the oil side converts to 21,000 PSI of fuel injection pressure at the wide open throttle. So that's a huge difference because that piston's got so much more surface area. And when it sprays out. The high pressure oil on top of the intensifier piston forces the plunger down, which in turn forces the nozzle needle to lift, and then pressurizes the fuel in the plunger cavity and ultimately opening the nozzle, sending fuel in the combustion chamber here. So it comes around at higher pressure, enough to overcome the spring, and then it sprays out through there. And then when the injector cycle is complete, the solenoid de-energizes, allowing the poppet valve to close off the oil inlet, so it goes back to where it was. And then the intensifier piston returns to where it was, and the fuel pressure is now too low to overcome the spring down here that's holding the nozzle closed. So we need this intensifier piston with the oil in order to overcome the spring pressure with the fuel pressure in order to have it spray. So it's kind of a complicated system. I don't think it really needs to be that complicated, but it is. And they don't use them anymore because I guess there's some problems with them, but they really don't use that type of system much out there anymore. You're just going to see it in those older vehicles. And then Ford common rail injection on the newer engines, so 6.4s and 6.7s, uses high pressure common fuel rail, electronically controlled again. Use an electrical connector, high pressure fuel, 26,000 PSI or so, and piezoelectric coils inside the injectors. So they're called piezoelectric injectors. Gasoline direct injection vehicles use it. Diesel injection, of course, uses it as well. So here's my whole injector unit here, and it's very, very similar. Like I said, if you watch the gasoline direct injector class, it's pretty much the same operation. So we have piezoelectric activation, stroke amplification, hydraulic control, and then fuel atomization on the bottom. So this is kind of like those HEUI injectors, but just way more advanced. We still use a little bit of oil in there. So first thing we talk about is a piezo stack right here on the top. All right, so this is used in multiple applications in the automotive world now. Like I said, mostly in the injectors, you're going to find a big stack like that, but a NOx sensor is also kind of works in the opposite of this stack here, and it'd be a much smaller stack. These wafers, call those piezoelectric wafers here. When you send electricity through them, they will move. When you put electricity, a current through them, they'll move. Versus, like I said, on a NOx sensor, it goes the other way. So when it moves, it generates a current. So either current comes in or current goes out, depending on what it is. So we see we apply current to it, and we see how that piston pushed out. Then we remove the current, piston goes back. Piston goes out, piston goes back, piston goes out, piston goes back. Just goes back and forth a few times. Next is the intensifier. So this has we have some springs there. We have a little another nozzle in there. We have another piston over there. So piston there, piston there. This is on the end of the piezo stack. So the piezo stack will be pushing on that. And what this does is it intensifies the stroke, makes it longer as it goes down. So we have a little spring around the outside. We have a spring, actually coil right here, spring right here, spring right there. When the piezo stack pushes against this coil, when there's nothing in here, doesn't do anything. It just kind of sits there, floats free. But if I add in here, go through this a little bit. If I add diesel fuel in here, it's going to come around once it opens up. We allow the diesel fuel to come in here, and now it has a hydraulic coupling. We have hydraulic, would be hydraulic because it is a fluid. Push on this side a little bit, it intensifies and pushes on that side a lot of it. So you can see the difference in stroke. It's almost double. So it pushes on there, pushes this out, strokes a little more. So it allows it to intensify the pressure and lengthen the stroke. The high pressure fuel comes in here. It allows this poppet valve to move, which allows it to overcome the spring pressure once again. Goes in there and allows it to spray fuel. As you can see how it's spraying the fuel. Very similar in design to that hydraulic unit, except we're using this piezoelectric stack to push it. Now, these things can react super fast too, if you remember that from the gasoline direct injection class as well. They react super fast. They can fire multiple times in a sequence. And then if we look down at the nozzle area, like we said, we got a spring. It's going to push it down. And then once fuel's in there, it's able to overcome the spring pressure. So the fuel pressure on the backside and the tension of the spring keep the nozzle needle closed. When it opens up, when the pressure in the control chamber is reduced, the nozzle opens. So that poppet controlled the nozzle, and then it able to overcome the spring pressure, sprays out the nozzle down the other. Able to spray multiple times a second, as we said. It can be milliseconds that we're spraying here. There we go. So that's the basics of how the three main injector types work. Now let's look at a couple actual real world examples of some things we might need to do with these fuel injectors. First off, let's go into the old one and go to an 03 Ford F350. So in this case, what we have first we'll look at guided component tests. So this would be, these tests are available on any Snap-on tool with a scope. So a Triton or a Modus or a Vantage or a Zeus or a Varus, any of those tools would have this database in there. But you could also use any old scope with it in order to test any of these things. So we got injection control pressure sensor. That might be something we want to look at. Injector pressure regulator be something we want to look at. Fuel system, we can go in there and look at the fuel injector as well. So we can do a resistance test on it. So in component operation, these are the HEUI injectors. Hydraulically actuated by high pressure engine oil supplied in by the high pressure oil pump. They have three major components which contribute to higher injection pressure. First component is electro-hydraulic injector amplifier piston, which operation is controlled at a solenoid operated poppet valve. So that's the top part, pulls it up. Second component is electro-hydraulic injector fuel plunger, which has been being driven by the amplifier piston and injects high PSI fuel into the combustion chamber through the fuel rails located in each cylinder head. And the third is a high pressure oil system that's controlled by the PCM through the IPR injector pressure regulator valve and is monitored by the PCM through the injector control pressure sensor signal to provide proper oil control and fuel PSI operation. And then it gives us our harness connector over here. We got glow plugs go through there as well as the injectors. We got a feed circuit and we have a control side. So it really has an open side and a closed side. Here's where we get into some interesting, on this particular engine, get some interesting decisions that were made in engineering. So the best place to test it, it's at the valve cover wire connector because it actually goes into the valve cover in order to get there. And there are some problems with that where it kind of passed through. You'd get some wiring harness problems with these. They're actually located under the valve cover, and you're going to test at the valve cover gasket inboard wire connector. So there's what the connector looks like right there. So that gets a little interesting with that. And I'm going to show you a scanner test that we can do with that as well. So in this case, key off this connector at the valve cover. So in this case, we're going to unplug it and we're going to check the resistance of the circuit. So you're going to measure the resistance at each injector, red and blue across the terminals. Resistance should be less than 2 ohms. Always check connections between valve cover and the glow plugs as well. So we can see the different injector feed circuits there. So we want to check, make sure we got good circuits between all of them. Now, like I said, there was a special test that was developed because they had these problems. But let's go into Shopkey first. I want to look at the wiring harness. See what we can see. $350. Why'd you ask me before? There we go. All right, that should be fine. So let's look at fuel injector. And let's say we're replacing it, right? So it's TSB's on it for sure. Let's see, customer satisfaction program, combustion seal on 6 liter. And then that's for non 7.3. So that's no big deal. Let's go down to my wiring harness though. My wiring diagram. Okay, looks like the injectors are on page 3 of 4. So we'll go in here. We'll just say it's a California vehicle for ease of use. Okay. Okay, so there's my system. Pull up my wiring a little closer here. So you have the injector driver module at the top. And then we have the fuel injectors down here. So you see we have a common ground on there. And then we have individual feeds for each of those. So common ground and individual. So with that, though, we see that there's a connector right here. And that connector that goes across, we see the different pins right there. That connector goes in the valve cover. So that makes it, if we have an issue somewhere underneath the valve cover, if we have a problem going through the valve cover, that's where it comes into a problem. So we're going to go into our scanner. And doing this on a simulator doesn't always work that well. 50, 3, there we go. And engine. See. Functional tests. And there is an injector buzz test. So this injector buzz test was created because it had that problem. So what it would do is engine off, turn off AC, all accessories, you're just going to leave it sitting there. And then when you hit continue, what it's going to do is it's going to buzz the injectors. So key on, engine off, going to verify the key is on, don't start the engine, hit continue, and it's going to buzz each injector. First it buzzes all of them, and then it's going to buzz individual injectors on there. And if you don't hear them buzz when it's supposed to be going through there, then you have a problem in the wiring. That is the problem. So it's going to go, it basically goes through a self-test, and then it gives you codes back at the end. Now, since I'm not hooked up to a real vehicle, I'm pretty sure I'm not going to get any codes back. So I'm just going to back out of it. So that's an older Ford, the HEUIs. Let's go to a newer Ford. So we got an F-350, 2019. In this case, series, there we go. In this case, in the engine, what do we have? So you got some special functions in here. So if you need to do DPF or SCR stuff, you could do that. There's fuel injector quantity adjustments. So if you weren't here at the beginning to see the intro video, there is every time you replace one of these injectors on this vehicle, you need to go in and do what they call an injector quantity adjustment. So it's a special code that goes with the each injector. It's a 10-digit code, and you're going to type them in order to program the injector to the vehicle. So we need to make sure we have to do that. So you're going to go, it's going to tell us what the codes are currently. And then we can go in and edit. We can type over what we need to do. If we wanted to do that, say, we can just hit OK. And then it's going to come up. Do we want to program it? We'll hit program. And it's going to say we're okay. And then it just gives us what we have. Easy enough to do. There's just a little barcode that comes with the injector, and you can do it that way with that. There's also another test that we have in here, the power balance test. So this is very much like the factory tool. Actually, it's a little bit better than the factory tool because we can turn off individual cylinders as well. So make sure excessive RPM and rapid RPM changes. Test will disable the fuel injector compensation strategy and make sure the parking brake's engaged because we're doing it while it's running. In park or neutral. And this is just an example of what it would look like if we had a couple issues going on here. So this tells us the RPM, tells us it's basically a cylinder contribution test that I can also disable injectors. So if I were to disable an injector and we saw it go way down, it's going to say it's not contributing. So it's a negative contribution. This one's overcompensating. That's the simulator's fault for that. But we can see how it kind of goes up and down. If it's a normal running engine, it'd be pretty flat. And then if we have a problem in a cylinder, it'll drop down. And then for some reason, we have way too high on that one. Like I said, that's not, you wouldn't normally see that. But there's also a history in here as well. So you can see, okay, was it having a problem before? And then it goes up. And then if you disable the injector, like say I disable number one, then it would go down like that. And then you just enable them back all. You can go in there and do that as well. So this isn't going to react because it's on a simulator, but on a real live vehicle, that's what it would look like. So that's on Fords. Let's go look at something else. Let's go look at a, let's see. Where is it? There we go. Silverado. On the Silverado, I forgot to look in here on the Ford, but it's going to be the same type of thing. So if I go into the fuel and the fuel injector, piezoelectric injector, they turn off on and off very rapidly. So this is going to use those piezoelectric injectors like we looked at the end. That 2019 Ford also uses them. I just didn't go in here. In fact, depending on load and throttle conditions, the PCM may turn on the injectors more than once, 3 to 5 times during the compression stroke. Kind of like a multi-strike ignition except for fuel. This helps reduce knock by allowing more gradual burn. That's more for gasoline engines. But yes, it can turn on once or twice for 400 to 650 microseconds in that case. Current rises to open the injector and the current inverts the opposite direction to quickly close the piezoelectric injector. And this gives the ability for the ECN to push the pintle open in one direction and then pull it closed in the other. Momentary high current to open the injector at the point there's virtually no current flowing. And then the injector stays open until the current reverses polarity to close the injector. This new type of direct injection system allows the computer a much wider, precise variable range of injector pintle opening control as compared to a conventional injector. For example, Duramax diesel firing order is 127845563. So the injector companion, they have companion cylinders. So 1425768 and 3. There's a fault detected in a group of injectors. Both that cylinder and the companion cylinder will be shut down at the same time. Shows each individual injector connector here and each wire color. And then we have at the actual fuel injection control unit. Best place to test it is at the injector. The injector is mounted in the middle of the combustion chamber, fuel and electrical connector on top of the valve cover at each cylinder. And then with that, we could do a resistance test, a signature test, and a current ramp test. So in the signature test, we're going to be looking at the voltage. So if I come down, actually, we've got to do the warning too. So according to GM, the voltage is supplied up to 160 volts at 20 amps and can peak up to 240 volts. So don't touch it while it's running. Try not to touch it. The scope can handle 400 volts, so you should be fine with that. And then it gives us a couple examples of injector power feeds. You might also have a sympathetic pulse on the companion cylinder, it says there as well. And then if I do current ramp, we're going to use a low amp probe to do current on this. And then if we scroll all the way down to the bottom, we're going to see what that looks like. All right, so we can see we have a positive and we have a negative on the current there. So momentary high to open it, holds it open, and then a momentary low to close it. So you see a spike up and a spike down on these particular injectors. So also on the Silverado, it's going to be the Duramax engine anyways. Come in here. Okay, there we go. Also on the Silverado, we're going to have a few tests that we can do. DPF test, module setups, reductant system. The power balance test is going to be very similar to what we saw with the Ford there. So we can turn the injectors on and off individually, and that's going to help us tell, is that injector feeding the cylinder? Because I don't have ignition, right? So I don't have to turn off spark plugs or anything. I have to turn off the injector. We can see whether or not that cylinder is actually contributing or not with that. All right, and then not to leave out Dodge, we're going to look at a Ram 3500. Okay. Oh. Gotta wait for security link. Even on the simulator. Go. Okay, so we have functional tests in here, which are going to be things like bidirectional controls, lift pump, things like that. Then we have system tests. So bring us in here if we have after treatment or DEF. We have fuel pressure override, fuel system run-up test for our fuel injector kill tests, and the high pressure fuel system test as well. So you can go in, you can kill single or multiple injectors, same type of thing. If we want to do misfire diagnosis and we kill an injector and it doesn't change anything, then we can suspect that injector and then we can go in and actually test it. So if I were to go in here under my component testing, and we go to fuel, this is a little bit different because we got the control actuator, pump relay, transfer pump, pressure sensor. We don't have injector tests in here because they are a little bit different with that. And the last one we want to talk about is going to be, not to leave out the European folks, or at least the folks that work on European vehicles, or at least Sprinters. Sprinters have diesel engines in them as well. Pull up an 18 Sprinter. Okay, so we go into our engine, and it's going to tell me I'm a simulator, so I got to choose some stuff. Okay, codes, data, functional tests. We have some special functions in here, which would be injector programming, just like on the Ford, but they're using a QR code instead. When replacing an injector, it's essential to save the QR code of the new injector in the engine control unit. The process ensures the necessary correction parameters for the injector will be recorded in the ECM. These correction parameters enable the engine control unit to meter the injection quantity precisely. So if they continue, it's going to give me a place I can plug it in. 7 characters and located at the top of the relevant injector. Can be hard to see at times. Since it's a 6-cylinder, we can go in there, we hit OK. Once we're done, same thing, we'll edit it if we need to. We hit OK, and then we're done. Again, simulator, it's not going to do anything. And as far as actuator tests, it's just me some fans, fuel level sensors, etc. So that one doesn't have a lot of controls for the injectors, but we do have the adaptations and the injector programming in there. And then for guided component tests, going to be pretty similar. So in that case, we go to fuel. There it is. So for the fuel injector on that one, it's going to be piezoelectric as well. Like I said, a lot of manufacturers have gone to this piezoelectric injector now. So just be aware. And then on this one, if we do current, ramp, and signature, it's going to be, actually we look at, so that has the positive and the negative current. And then the signature tests, I think we can do both, yeah. So this is going to be control side and ground side as well. So we can see what the different multi-strikes look like on that injector. So a few differences. We know how they work. It's going to be fairly easy to test. Very similar to our gasoline direct injection vehicles we talked about before as well. So hopefully you get a little bit better understanding of how they work and what the manufacturers do, and a few things to look out for as well when it comes to, say, I need to replace an injector. I need to make sure, A, I need to worry about the pressure, and B, when I do replace it, I do have to put information into the computer many times as well to put the flow rates in there. So with that, that is my time for the week. Let's talk about next week. Next week, we're going back to code-based diagnostic workflow. We do a 2-part series that we do, and it's going to help you walk through, hey, if I have a code it's a good idea to have a solid workflow instead of just bouncing around willy-nilly. We don't want to forget anything. So having a good repeatable workflow can really help you out when it comes time to diagnose with a code. So if you want to join me for that, 6 to 9 Eastern. If you want to go into Zoom, snapon.com/OT to reserve your seat there. Otherwise, the 6 p.m. class goes to YouTube, youtube.com/Snap-on Diagnostics. If you are watching this on YouTube, please make sure you're subscribed because we find that a lot of people watching the videos aren't subscribed. So it would really help us out if you were. And also, it allows us to keep giving you this free training content as much as we can. You want to see any of the older classes or the previous classes that we've done, like ADOS, data bus testing, the whole component test series we have back there, VBT, etc. All of that is available for free on our YouTube channel as well. So youtube.com/Snap-on Diagnostics. There is a playlist for live training. And by the way, this is episode number 50. So we're now up to 50 different half-hour, 40-minute classes that you can take to walk through on multitude of different things on vehicles, components, and different types of air conditioning, pressure transducers, all sorts of different items on a modern vehicle, how we go through, test it, theory, operation, all that good stuff. All available for you once again on YouTube. Okay, let's get to questions. Before I do that, I want to make sure I talk about my buddy Al. So Al also offers free diagnostic training on Monday, Wednesday, and Thursday. So his is vehicle-specific training. I mean, not vehicle-specific, scanner-specific training. Monday's on Apollo, Wednesday's on Zeus, and Thursday is on Triton. So if you have any of those tools, it's a good way to go through and check it out. It's going to walk through. Let's make sure your Wi-Fi is working on your tool first. Then let's make sure we set up your free Snap-on Cloud account. We want to make sure that's working. And then it walks you through everything, head to toe, code-based, walking through fast-track intelligent diagnostics. How does it help me out as a technician diagnose a car faster, easier? So that's the first hour on any of them on their respective tool. Then after a 5-minute break on Wednesday and Thursday, since these tools have scope and meter functions, he walks through the scope and meter functions for another hour. So these are very comprehensive classes. If you want to learn how to use your tool better, if you just purchased the tool and you want to learn how to get the most out of it, check it out. If you want to get a refresher course on it, same thing. Same time, 5 and 8 Central, 6 and 9 Eastern. Go to snapon.com/OT. He only does those on Zooms because they're kind of more of a smaller, you can ask questions, that sort of thing type of class. So definitely check him out. All right, let's look for questions. On Zoom, if you do have any questions and you see the Q&A box, you can type in the Q&A box right there and I'll get to those. Bunch of stuff on YouTube as well as usual. Thank everybody for joining me so often on YouTube every week. Raymond, hello from Yonkers, New York. Welcome. Good to see you. Salim, hello. Welcome. Nick, always chiming in from the UK. Very welcome. Very late in your world. I know 11 o'clock at night. So definitely check that out. Thank you for checking us out. Peter Arjun, hello. HEUI, thank you for checking in. Abel, welcome back. Good to see you as always. Let's see. Carter asks, any chance do you know if Snap-on is working on a diesel induction cleaning tool? I am not sure if they are. There was one, the EEDF 400, but it was discontinued. I'll have to check and see if we do have. I'm not aware of that side of the business, so to say. But I can always find out and see if we do. So I will check into that for you. And the Winton, hello, welcome. Thank you for joining us as always. Good to see you chiming in as well. So looks like we cleared the board here. Give YouTube another little minute here because I know there's a little bit of a delay, about a 20-second delay on YouTube too. Don't forget my buddy Al. With that, thank you very much. Definitely appreciate you taking time out of your busy week to come and see me. Hopefully we got a little bit of more information, a few tips and tricks on how to look at fuel injectors, diagnose fuel injectors, how they operate on the diesel side of things, how a little bit of difference between the diesel and gasoline world, but definitely some differences, but a lot of similarities as well, especially when we get to direct injections. So with that, thank you again. Enjoy the rest of your week. Enjoy your weekend. Hopefully we'll see you next week for code-based diagnostic procedure workflow. And have a good night. Take care.